Um, Hi everybody, my name's Lishba. I'm 16 years old. I'm in my first year of college. I'm in year 12. Um, After college, I aspire to study physics at university. So someday, I can become a physicist. Personally, I'm really interested in particle physics and astrophysics. Um, this is my first video on my YouTube channel. So, hello. Um, Hi. Um, Aside from that, today I want to talk about neutron stars. Neutron stars. Neutron stars, I think. Um, Neutron stars are formed when high mass stars about 8 to 30 solar masses die in supernova explosions. So something really interesting happens in the core of massive stars um, when something really interesting happens to the core of massive stars. This is known as this is known as this is known as this is this is known as electron capture. So electron capture is when a proton and an electron merge together and form a neutron. This thing is really similar to inverse beta decay. Inverse beta decay, where a proton decays into a neutron, emitting a neutrino, or a neutrino decaying into a proton and emitting an electron and a neutrino. So neutron stars are also really dense. They're typically about the size of a city. So you have the mass of 1.44 times the mass of our sun, of the sun, to about 2.7 times the mass of the sun, crammed together and crammed into the size of a city. So that's they're really dense. So due to those densities, neutron stars might contain really exotic due to due to um due to the incredible densities of neutron stars. Um, the gravity is really strong. Um, it's actually hard. The escape velocity of a neutron star. Well, the escape velocity of a neutron star is half the speed of light, so about 150,000 kilometers per second. So yeah, they're really strong. And if you were to in any way um if so yeah neutron stars can also some neutron stars emit electromagnetic radiation from the magnetic poles. So neutron stars that do emit neutron stars that emit electromagnetic radiation from the magnetic poles are known as pulsars. So pulsars were first theorized by a physicist known as Franco Pacini. I'm sorry if I mispronounced his name. So um so a physicist named Franco Pacini theorized neutron star pulse theorized pulsars first, and in 1967 pulsars were first detected by astrophysicist Jocelyn Bell Burnell. At first, pulsars were thought to be extraterrestrial. At first, pulsars pulsars were thought to be aliens. Actually, that's why they were first. They were also known as LGM for short. Um, Obviously, at the end, um, it was found out that pulsars are actually just neutron stars that emit electromagnetic radiation from the poles, from the magnetic poles. If um if the magnetic poles happen to be pointing towards Earth, then we can detect them using radio telescopes. Some pulsars can also emit electromagnetic radiation in different wavelengths, for example, gamma rays or optical waves. Actually, there's a I have an image of a pulsar. I have an image of the Crab pulsar from the Liverpool Observatory. Actually, so neutron star mergers can also happen as well. So neutron star mergers happen when neutron star mergers are first detected by gravitational wave observatories LIGO in America and Virgo in Italy. The first gravitational wave signal detected was known as GW 1708-17. So this gravitational wave signal was detected back in August 2017, and it came from two neutron stars colliding about 130 million light years away in the galaxy NGC 4993. So yeah, it's really far away. Now, typically in neutron star mergers, some mass is radiated away in the form of gravitational waves. So the resultant object from the neutron star merger would be less than the sum of the previous than the sum of the masses of the neutron stars merging. There's also a really interesting gravitational wave signal detected by LIGO and Virgo as well. This gravitational wave signal, GW 1908-14, was really interesting because the mass predicted of the resultant objects was thought to be in between the Tolman-Oppenheimer-Volkov limit and the minimum mass of a black hole. So there was no optical signal detected. For example, like normally in neutron star mergers, other forms of other signals are detected as well. Like for example, optical light can also be detected. Gamma rays can also be detected, or radio waves, as well as gravitational waves. However, for GW 1908-14, there was no other signal detected other than gravitational waves. So no one knows what the resultant object is, whether it's a neutron star or a black hole, because the mass is in between the minimum mass of a black hole and the maximum mass of a neutron star. So I think that's really interesting. Since neutron stars are really, really dense, you have about the mass of 1.44 solar masses to about 3-ish solar masses packed together in the size of a small city. The conditions are incredibly dense. No one really knows what's exactly in the core of a neutron star. Some people speculate that some exotic forms of matter would be found in the cores of neutron stars. For example, quark gluon plasma. If in really, really extreme conditions, quarks can separate. Usually, quarks are never found alone. They're always in pairs with another quark, usually in the form of mesons mesons, like usually in the form of mesons or hadrons or baryons. Usually quarks are never found alone. For example, they're always found in with other quarks, usually in the form of hadrons or baryons. So other than that, some people speculate that a special, a very special type of some people speculate that a type of hadron known as a hyperon can be found in the core of neutron stars. So hyperon is basically a hyperon is when a hyperon is a type of particle where which is composed of one strange quark and either two up quarks, two down quarks, or one up quark or one down quark. So hyperons carry a property known as strangeness, and usually which makes them really, really interesting. Neutron star mergers can also create lots of heavy elements. For example, gold, silver, platinum, or uranium are formed in neutron star mergers. Since neutron stars contain neutrons and neutron-rich isotopes, lots of heavy elements can be created in neutron star mergers. Usually lots of radioactive elements are formed in neutron star mergers, but they decay into more stable isotopes. It's getting a bit late, so yeah, that's all for today. I'm gonna make another video on supernovae and neutron stars again soon. Bye. So I'm gonna make another video on neutron stars and supernovae tomorrow. So that's it for today. Bye.